Hello, everyone. Thanks for joining another Cyber Skyline Live. I'm Franz Payer with Cyber Skyline, and I'm here to help you learn about cybersecurity. We run these episodes for you, so please stick to the end and let us know what topics you want us to cover next. This week's topic is exploiting untrusted web data. So I'm just going to jump straight into my slides, but please ask any questions you have as we walk through today's show. I'll look in the chat and walk through them as we get to good stopping points. And as always, if you're watching this as a post recording, leave your comments and questions in the chat, and we will try to get around and answer those as well. So without further ado, let me switch over to my slides and let's talk about the web. So when you are visiting a website, there's a series of things that happen for your browser to actually load the website. And basically the premise, the short of this is that your browser will make an HTTP request to the server. That is the actual thing that is going over the internet. So you go type in cyberskyline.com, a request goes out over the internet. That's the HTTP request. The server will receive that request and it will perform any necessary action. So if you're trying to log into a website, it's going to take in your username and password. It's going to check its database and see, is there a record in there that matches that username and password? After it does that, it will send a response back. And that response will say, okay, that was successful, it was not successful, or this is my homepage, this is whatever. So all these different requests are coming to the server. The server is looking at these requests, it's fulfilling these requests, and it's responding back to the client. The browser will then execute the code that is provided by the server in the response. So if you are going to a website for the first time, the very first thing that gets as a response that you'll get back is, here is the code to load the homepage, as an example. It's going to tell the browser how to actually display the page. What often occurs is that there are things on that page which require additional HTTP requests for your browser to be able to load. And so you'll have one initial request, which is basically, give me the blueprint for your homepage. Give me the blueprint for this one page that I'm trying to load. And as your browser is trying to display that and run that blueprint, it is going to make additional requests for the other components on that page. All right. So this is what the actual request and response look like when that request is being made. On the left side is the request. So I'm just going to start at the very top. You can see the words get, and then you can see a /contact, and then HTTP/1.1. So let's break it down. The get is a specific type of request that is being made by the client. And the /contact is the specific page on the website that is being requested. And the HTTP/1.1 is the specific version of HTTP that this request is being made with. And so this first line here is telling the server, I want to load this page, and I'm using the format for my request is using HTTP 1.1. Below that, you will see what are called headers. These are key value pairs, which you can sort of treat lightly as metadata, but not quite. Sometimes it contains more important information than what I would consider metadata. But in this case, you can see information such as accept text/HTML. That is specifically saying, I am expecting the result of my request here to give me a text file that is a text HTML file. And so the browser can use that, the server can use that information to determine what format the data should be sent back as. And then there's also this information about the host. This is the www.cyberskyline.com. Oftentimes, when requests are sent to servers, they might get forwarded to different servers, and you might have one server that's actually handling requests for multiple different domains. And this header allows that server to know which specific website this request is for. The headers here, these are just two headers. There are much more than just these two headers in existence. You can go on Wikipedia, you can look up a larger list of these different headers. But for today, we're only just looking at these two. On the right side, you're looking at response headers. And so the left side is the request that gets sent by the browser. The right side is the response that the server sends. Again, you can see this is all just text. And so you can see exactly what is being sent back and forth as a human readable format. The server will respond by saying HTTP 1.1 is acknowledging that I'm sending back using the same protocol that you're using. And then you see this 200, that's the status code. The 200 numbers indicate that it was successful. 300 indicate there's some sort of redirect. 400 indicates that there's an issue by the client. And 500s indicate that there's an issue with the server. And you also see a status code. Next to the status code is the status message. Okay. And then you have all this metadata. And you can see there's a lot more than that. And then below the metadata, there's a little bit of a gap. And then there's the body. That is the substance of the response. And in this case, you can see there's this HTML information here. Now, this is really important. When you want to look at web security, you're trying to figure out how do I break into this website? Generally speaking, what you're doing is you are trying to figure out what request can I send to the server to do something that is unintended. I want to abuse some sort of system. I want to break some sort of assumption that they're making. And so being able to read and understand these requests and responses is very important for you to figure out how do you actually go about exploiting a website. That's why we're going into that today. Now, we've covered, generally speaking, how requests and responses work. We're going to go into a little bit more detail in the latter part of this episode. But I want to focus right now on specifically the GET and the POST as a very quick summary. And so GET requests that's what you saw in this previous example here. This is a GET request on the left side. A GET request specifically is about trying to fetch some data without making any modification on the website. So you see this when you try to visit a homepage, when you try to get an image. You're not modifying anything. You're just trying to obtain some information. There's also POST requests. This is when you're trying to make a specific change. Like you are, let's just say you're making a post on Facebook, right? You go to Facebook, you want to make a post, or you're on Twitter, you want to make a tweet. You are typing in your message and you're hitting a button, and that is getting published on the website. So there is a specific action that you're trying to take. So GET requests are meant for fetching data, and POST requests are meant for taking action. You're trying to do something with the server. The example here with the server response, you can see that there's this HTML, and you're probably wondering what is HTML. HTML is the hypertext markup language. This is basically a language that is used, I defined it as creating a blueprint earlier. You can also see it as a skeleton for a web page. And it tells the browser how the information on the page should be laid out. It will also contain assets, references to other assets. So for example, you might have an image, or maybe you have some CSS. CSS is used for styling, making your buttons look pretty and changing the colors of things. It might also have JavaScript, which is responsible for actually performing operations and logic on a web page. All of these different assets will be made as separate HTTP requests. So the first request, when you go and type in cyberskyline.com, the first response that you're going to get is going to be for the HTML of the web page. That is the blueprint for how to load the page. The browser will look at the HTML and say, okay, I need to get these 10 additional resources to be able to fully render the page. And what you're seeing here highlighted in this code snippet is the HTML, And there's actually, you can see a reference to this style.css file. There's also this jQuery.min.js file, and there's also this main.js file. And so these are the links to those other resources and assets which will be used to give the page its look and its functionality. What is really interesting here is specifically this main.js file. The logic on a website will typically be bundled into multiple JavaScript files. And some of those JavaScript files are what are called dependencies. They're other libraries of code that some other person wrote, and the developers of this website are reusing that code for simplicity. So if someone wrote a lot of code to help you make login pages, or to help you do hashing, whatever it may be, you can import that code, and websites are no different. They will import that code and you'll be able to see it in the HTML. I'm highlighting this main.js because that happens to be where all of the logic for this website is stored. And today our target is this web page. So if you have access to one of the gyms in Cyber Skyline, this is available within the web application security section. This is the online lottery. And we are going to be trying to figure out, how can we win the lottery, right? How can we buy enough tickets to win the lottery, even though we have a limited amount of money? And we're going to look into the code to figure out exactly how to do that. So I mentioned JavaScript. JavaScript is going to be very important for what we're doing today. And to help you understand why it's important, there is that purchase tickets button, right? So from this page, there's the purchase tickets button. When you press that button to purchase tickets, a request goes to the server to actually purchase those tickets. And JavaScript is responsible for specifically creating that request. And so if we can look at the JavaScript, we can see how are the developers making a request to the server to buy these tickets. And if we can see exactly how they are making those requests to buy the tickets, maybe there's something that we can do to create our own request, which allows us to buy extra tickets or something like that, so that we can win the lottery. All right, so I specifically pulled out the code, the JavaScript code, and we're going to dive into this in the demo today. But I just wanted to quickly highlight and show the main snippet of code, which will be important in today's session, which is, this is the request that is going out to the server. And in this request, you can see there's this data section, and it says cost, and the cost is set to cost times number of tickets, and the tickets is equal to tickets. So it appears that when a request is being sent to the server, the cost is just taking the unit cost and multiplying by the number of tickets, and then we're going to buy the number of tickets that we say we want to buy. So what happens if we make a request, instead of using the JavaScript code in the website to make the request to buy the tickets, what if we wrote our own JavaScript code and we made our own requests, and we bought more tickets than we're supposed to, or we bought them for cheaper than we're supposed to? Then if the server does not properly check to make sure that the cost adds up to the amount it's supposed to, then we can abuse that system, and we can actually buy way more tickets than we're supposed to be able to. So how are we going to go about doing this? There's 3 basic steps. The first step is we need to find the code as the basis for us to, we're going to basically just copy the code. We're going to make some modifications, right? So that's going to be the basis for our actual attack, our exploit. And the second thing that we're going to do is observe the normal behavior. So we're going to see what that request looks like when we hit the button. What does the request look like, and how can we manipulate that in the way that we want it to? And the third thing that we're going to do is actually go and make that request. And so to find the code, there's two primary ways you can do this. There is there's a very basic method, which is right click, view page source. And that will give you the HTML for the web page that you're looking at. Now, once you have the source, the HTML, you can go and look to see if there's any JavaScript files, open them up and see, is this a JavaScript file of a library of someone else's code base, which maybe I'm not interested in looking at right now? Or is this some code that developers for this website specifically wrote? And can I go and analyze the code that they wrote for that button? Another way that you can do this is to open the developer tools in the browser. You hit F12, and you by default, if you hit F12 or if you do a right click and inspect element, it'll actually show you the HTML for that page, and you can see any of the JavaScript files that it's loading. Another thing that you can do, which I covered in step 2 actually, is if you go to the network tab in the developer tools and you refresh the page, it will actually show you all of the requests that the browser makes to get the HTML, to get the JavaScript files, to get the CSS. You can see each one of those requests happening, and you can click on those files from there. When it comes to that step number 2 of observing normal behavior, you're going to want to go to the network tab, keep the network tab open, and then make the request to purchase those tickets. It's very, very important that you have the network tab open before you actually go and make that request, because most of the browsers won't actually start logging that information until you have the tab open. So open up the tab and then make the request. And then you're going to finally go and make that malicious request. You're going to go to the console section, the console tab in the developer tools, and that will allow you to type in your own JavaScript code and execute it on that page. And what we're going to do is we're going to look at the code. We're going to see what the request looks like when the request is sent to the server. And then we're going to modify that code to craft the request that we want to get all the tickets to win the lottery. That's our goal for today. So I'm going to jump over and do a quick demo. As I'm getting this set up, please ask any questions in the chat, and I'll answer them as we go through hacking this website. All right, so I now have the website pulled up over here, and you can see this is the form on the left side, the form where we order our tickets. On the right side, you have a countdown. The reason why there's this countdown is to give you many opportunities to attempt to win the lottery without having to wait multiple times for another drawing. So the drawing happens very quickly. It happens every 15 seconds so that you have many opportunities to actually go and try to break the lottery. So the first thing that I mentioned is viewing the page source. And so I'm going to right click. I'm going to do view page source. You can see it over here. And this is all the HTML for the page. All of these blue links are resources that the browser is going to be loading when it is rendering this HTML. And so you can see here, this is the main.js that we showed in the slides. If I click on this, I can actually go and see this is all of the code that is written for this web page. Another way that you can get this information, I'm going to show the second way of doing it. I'm hitting F12 right now, F12, and that pops up the developer tools. And you can see right now that under this network tab, it's currently blank. And that's why I said you have to open the network tab before you do anything, because it'll only start recording after you open the network tab. If I refresh the page now, you can see all of the requests that the server made. The first request is for the web page itself, and this has the HTML. Sorry, what? Okay, I need to uncheck this because it's including some additional information that I don't want. So in this first request, you can see the HTML that we just saw, when we did view source. This is the HTML in the initial request to load the website. After the browser starts attempting to render this HTML, it is going to need to go and make the request to get this CSS file, to get this JavaScript file, to get this other JavaScript file, to get this other JavaScript file. And that is what you're seeing below. We can see here there's a chart min.js. Here's the chart min.js. After that, there's a main.js. Here's a main.js. The browser doesn't always get these requests, doesn't make these requests in order that they appear, but you can see that everything listed on here, the chart min.js, the main.js, over here there's this jQuery min.js, there's this bootstrap min.js, bootstrap min.js, jQuery min.js, or bootstrap min.css. All of this is being recorded when you open up the network tab. So this is a very, very helpful tool. And now that we actually have the code, so let me go to the main.js here. I can double click on this and it opens it in a new tab. I can read all the code here. If you're not an expert on reading code, if you don't have any computer science background, your goal is not to try to understand it perfectly, but try to guess as to what might be occurring. And so at the very top, you can see there's this document.ready. Basically what happens is it's saying that once the document is ready, once it reaches the ready state, it's going to execute all of this code in here. Something else that we can see here is there is this purchase on click, and then there's a function. So this is actually the core piece of code that we're looking at. And if you try to infer, you can probably guess that purchase might be referring to this purchase button. And when it's clicked, it's going to execute this code. And we can see here that there's a box that is trying to look up, and it's trying to get some tickets, and it's taking the box.val, that's the value inside the box, and parse int is parse integer, is trying to convert this value into a number. And then we get to this if statement here. If session.money is greater than or equal to session.cost times tickets. So session must be storing some important information about how much money we have and how much these tickets cost. And it's checking here if we have enough money to buy these tickets. So this is something we could definitely bypass when we make our requests. And you can see that if you don't have enough money, it says you don't have enough money. And if you do have enough money, then it is doing this Ajax thing. Ajax happens to be the function that is making the request to the web server. And you can see method post, here's the URL, here's the data, the data type is JSON, the content type is this. A lot of this information, the data type and the content type, these are part of the headers. And the method is part of the HTTP method. The URL is the URL. And the data is the data. And so what we can see is that we could probably actually just copy this and make some of our own modifications. So now it's time to go to step 3, where we are actually going in and trying to break this website. So what I want to do is I want to just collect a sample. What happens if I try to legitimately buy a ticket? What does that look like? So I'm going to come in here. I'm going to say I want to buy 1 ticket. And you can see our balance went down and our tickets went up. And I can see here in all of these requests, these are status updates. And when I click on this, you can see it's every single time there's a status update, it says how much money we have, I guess how many tickets are in the pool, how much the tickets cost, how many tickets do we have. Here's the flag that we're trying to get when we solve the question. And then here's how much time before I think the lottery drawing happens. And you can see that these status updates happen very, very frequently. Interwoven in all of these status updates is our purchase request over here. And so you can actually go and you can look at the request that was made. If I go to headers, I can see Here's my request. Here's the URL. And down here, if I look at the request headers, I can see that I'm making that application JSON request. I think that matches up to what we saw here. Content type application JSON, content type application JSON. What else do we have in here? Data type JSON. Do I have a data type in here? Doesn't look like there's a data type in here. But I can go and I can look at the payload. And I can see in the request payload, here's that data. So this data section over here with the cost and the tickets showed up in the payload. Cost is 5, tickets 5. Another way that you can look at this data is by using Wireshark and doing a capture, and you can actually see the HTTP request go across the wire. The browser right now with the developer tools is helping us parse out some of this information. It's actually, instead of showing it as a giant block of text, which is what we saw in the slides and what you would see in Wireshark, it's actually trying to print it in a nicer format so we can read it more easily. But the side effect of that is that you don't actually get to see exactly how the data is being sent over the internet. In this case, normally in an HTTP request, there isn't like sections that you can like collapse and fold. It's literally just a chunk of text, and the payload is going to be like together with all the rest of the headers in one giant column of text. But we can see here, cost of 5, tickets 1. If I go and make another request, I want to buy 2 tickets, hit purchase. We look at the next purchase request. We can see cost 10, tickets 2. All right. So let's actually go and try to write some exploit code. I'm going to go here and I'm going to copy and paste this code. I can see that we have an if statement here. It's checking if we have enough money. If we have enough money, it is running all the code in between these two brackets. And so I'm just going to copy that code that it runs. And if I go to the console section here and I paste it in, this is the code that I'm interested in. And if I try to run it right away, I'm going to get some errors. It's going to say session is not defined. That's because there's some additional code that executes before this, which defines some variables. And so we will need to modify this code so it'll run again. So we can see here that it says session is not defined. So clearly the session needs to be modified. So I want to say the cost is, normally the cost is 5. I'm going to say the cost is 1. And tickets, let's just say I want to buy 10 tickets for now. So I'm just going to replace these variables, which are not currently defined, and give them concrete numbers. So because in this code snippet, things like tickets and things like session are defined in the main code, but they're not defined when I just copy and paste the snippet, those errors will trigger. So I need to go and remove references to stuff that we don't have in our code and replace them with things that are defined. And I think if I run this again, I'll get another error, get update is not defined. This is basically code that runs after we get the response back. And so I'm just going to come in here and just delete that. And let's see what happened. So let me go back and look at the network tab, and you can see here's another purchase request. If I click on this purchase request, we can see cost 10, tickets 10. Now this thing resets every like 15 seconds. So I need to be quick on the draw. I need to make this request. I'm going to refresh my page, and I can see here I've got 10 more tickets and I lost $10. And it's going to reset again. And it's and now it's back to 10,000 and 2,000 tickets. So we know now that we can make a request to buy as many tickets as we want for as much money as we want. So what if I come in here and I just say, I want to buy my tickets for $1 and I want to buy, a large millions or billions, or I don't know how big that number is. I want to buy a lot of tickets, right? So let's run that request. We can see the response here. $1, all of these tickets. I'm going to refresh the page, and it looks like we got the flag. So we were successfully able to buy all those tickets. I think you have to be quick on the draw in terms of um, getting a request in and refreshing. There, I have like the 10 million tickets. If you want to be able to see your 99% chance of winning the lottery. The way that we have this challenge set up, I believe as long as you get a probability of like 80% or higher, you will quote unquote win the lottery and get the flag. And if you have less than that, you never get the flag. You're not going to automatically get the flag just by pure luck. You actually have to rig the lottery in order to win. But you can see the process now of going through and like trying to figure out what code is existing there on the website. How can I modify that code to serve my purpose? How can I see those requests going over the internet? And how can I craft a new request that I want myself to do something that is not supposed to happen, right? Normally, if I wanted to order, millions of tickets, it'll give me this warning that says I don't have enough money. So you specifically need to take the code, modify it, execute the code in the console to get exactly what you want in order to exploit the fact that the server here clearly is just assuming that the cost and the number of tickets are accurate. And we can take advantage of that to serve our purposes here. So that's a quick overview in terms of how are you exploiting an untrusted data vulnerability. Normally, in a secure website, the web server would check to see if the number of tickets that you're buying matches the price that you're sending it. Honestly, it probably shouldn't even be taking the price from the browser, from the client, right? It should have a record of the price on its own database and not look at what was sent by the browser. So if you wrote some code for a website to handle something like this, you probably would not want to take the client data as the truth for what these tickets cost. You want to use your own record of what these tickets cost. I'm going to jump now and answer some questions, but if you all think of some additional questions as I'm going through these, please ask them. And I'm happy to dive in. If you got any questions about reading some code or how the developer tools work, I'm happy to answer those as well. So Randolph is asking, is this something that can be done in Burp? And you're probably referring to the Burp Suite. So yes, so the Burp Suite is a tool that will allow you to kind of manipulate web requests and view all these web requests that are going across the wire, across the internet. Yes, you can use Burp to see those requests and to even modify requests so that you don't even have to write any code. You can skip what I did with the console here and executing this code and go into Burp and just like edit and say, okay, I want to send a request that has, 100 million tickets for $1 without having to write the code. I just want to go and edit the request. You can do that with Burp Suite. That's a possibility. Burp Suite probably is not as helpful for you actually viewing the source code and understanding how the JavaScript works. But in terms of solving this challenge and modifying a request to buy, millions of tickets for $1, you could definitely do that with Burp just fine. All right. It looks like that might be the only big question here. Betty, I'll stay on a little bit longer and see if anyone's got any final questions. But to kind of recap what we did here today, we went over what happens when you actually go and visit a website in your browser, right? There's an HTTP request that goes to the server. The server will send back a response, and that response will actually be HTML, which is code which builds the skeleton of a website. Your browser will then try to populate the website, fill it up with all these different resources which are specified in the HTML in that blueprint. From there, Whenever you are clicking a button, you're performing some sort of action. Anytime the website has to go and anytime your browser has to go and make a request to the server, you can actually open the developer tools and see that request happening. And so you can look at the JavaScript, you can look at the source code to see how are the developers crafting those requests. You can look at the network tab in the developer tools to actually see those requests firsthand. And then from there, you can create your own code to make your own custom requests. And looking at the developer's source code is a very quick way to be able to create those requests by hand very quickly. You don't have to reinvent the wheel. You can copy what they did and just make some modifications, um, and be able to do things like buy 100 million tickets for $1. I've seen another question. How do you refresh the page without refreshing the code in the console? I don't believe there is a good way. Um, so let me see. If I run this code and I hit refresh, I don't think there's actually a good way that you can do that. Now, there is usually history. If I hit the up arrow in here, I can see everything that I previously entered into the console. So if you're writing your own code and you accidentally wipe it, you can actually hit the up arrow and see it. Now, if you're referring to the code for the web page itself, you can always open up the JavaScript file in a separate tab like this instead of trying to read it from the developer tools over here. Like you could read the JavaScript directly from here, or you can like double click on it and open it in a new tab. Nicholas is asking, if there are multiple JavaScript resources, what would be the most efficient method to determine which script needs to be modified? So this is going to be a little bit of kind of like you start you start like figuring out trends when you get more experienced. But what I would recommend as a very quick way of doing it if you're completely new is take the file name and Google it and see if that is a name of a code library that is very popular. So for example, if I take this, I type in Bootstrap CSS like that, I can see that there's this website, Get Bootstrap, which is specifically documentation on this Bootstrap library, which is being used by, which can be used by other people. So if you're able to Google the file name and it comes up with a code project, that's a good sign that that is not something you want to be looking for. You want to avoid looking at these types of code dependencies when you're looking at these websites. You want to actually be looking at stuff like main.js. So if I go and type in main.js, there isn't a website project dedicated to a main.js code repository. If I go and type, and I can see chart.js, I Google that, you can see open source HTML5 charts for your website. These are code repositories. So those are code libraries. So you want to Google the name of the file name itself and see, is this some code that's freely available on the internet that other people are using in their own projects? If so, ignore that and only look at the code that the file name is not something that you can Google and find a project dedicated to something of that name. All right. Well, I want to thank everyone for joining us today. I'm putting up a poll right now to ask what topics you want us to cover in the future. We've got a lot of different options up there. If there are other topics which are not listed in the poll, please ask in the chat. We want to know what you want to learn about, and we'll make some episodes covering those to help you prepare for a career in cybersecurity. But thank you once again for joining us today. I appreciate all of the comments and questions that we'll be getting in the chat. And if you are not yet signed up for the National Cyber League and you want to practice solving challenges like what we showed today, this specific lottery website, and you want to figure out how to break into that, there's a button right now where you can, if you're viewing this on the Crowdcast, there's a button for you to register for the National Cyber League. If you're watching this in post, you can Google for the National Cyber League and register. Once you register, you'll get immediate access to the gym, and you can go and practice this firsthand and come back to this video and follow the instructions. So thank you once again for joining us. Hope you enjoy the rest of your day, and take care.